This is Physics 1 course. In this video I will teach position, velocity and acceleration vectors. So here I have drawn a picture of a street. So let's assume this guy lives here and his school is somewhere here and he's going to school every day, and in one day he just moves from his home all the way down the street, then goes a little bit up, passes the street, and then goes to school. Now let's say there is another student here who observes the other student. So therefore he defines a coordinate system whose x and y are like that. And now from his coordinate to the position of the student, the original, it will define a vector, just as the vector that we defined in previous videos. That is the position vector of the student. Now this position vector is a function of time because it changes, because at initial time the student was here, but finally the student goes here. So this is t2 vector. So position vector at t1 and position vector at t2. Just like any other vector that we covered in previous videos, I can write position vector r as x, which is a function of time, I hat plus y, which is a function of time, j hat plus z, k hat. Now let's define an average velocity. So let's say delta r, that means r at t2 minus r at t1, and divided by delta t, which is just t2 minus t1. This we call average velocity. Now if delta t goes to 0, if I have limit when delta t goes to 0, then it becomes the definition of time derivative. So dr over dt. This is the velocity vector, which is equal to dx dt I hat plus dy dt j hat plus dz dt k hat. Now let's say t1 is equal to 0, meaning that when he started moving, he started the stopwatch. So t1 is 0. Then we have t2 equal, that means when he arrived here is 20 minutes later. So 20 minutes later. Now the average velocity delta v, it's a vector again. We defined it here when the delta t was not 0. So it's rt2 minus rt1. So it's basically this vector. This is r2 minus r1. r2 minus r1 divided by 20 minutes. So now let's say from here to here it's 20 meters. So that means r1 is equal to minus 20 meters. I hat. And from here to here is only 10 meters. And it is positive. So it is plus 10 meters j hat. And let's say R2 equals no x hat, so 0 I hat. And let's say this distance is 25 meters j hat. So now delta V equals to 0 minus 20. So it's plus 20 meters I hat, 25 minus 10, 15 meters j hat divided by 20 minutes. 20 minutes. So therefore we have 1 meter per minute I hat plus 15 over 20 meter over minute j hat. Now let's ask a question. What is the direction of delta V? It's easy. It's the direction of R2 minus R1, because delta T is just a scalar. It doesn't change the direction. So delta V is in the same direction here. Now let's see what velocity vector actually is. Let's say I have a coordinate system, x and y, and a particle moves along this path. Now if particle at time t1 is here, r1, and at time t2 is here, r2, this is the average velocity. Now if delta t is very small, the particle can't move far away. It probably goes only a little bit, and therefore this little thing here is the velocity vector, dr over dt. As you can see, it is always tangent to the pathway. Now let's say this vector r, this path, is given by 2t to power 3 I hat plus 5t j hat minus 3 k hat. Then the velocity vector is dr over dt equals time derivative of the first component, x component, it becomes 6t2 I hat plus 5, this is the derivative, j hat, and the derivative of a number is 0, k hat. Now, acceleration vector, we usually show it with a, and it is again a vector. It's the time derivative of v, the velocity vector. Therefore, it is a second derivative of the position vector. We show it this way. So it is now a derivative of that. So it's 12t I hat plus 0 j hat plus 0 k hat. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.